All right, let's go on a little journey. We're heading miles underground into a world where the pressure can literally crush a submarine and the heat can melt lead. This, right here, is the world of extreme well testing, where engineers are working on the absolute edge of what is possible.
So, think about this for a second. How would you even begin to measure something so powerful, so unpredictable? It sounds like a dramatic question, I know, but it's pretty much the same challenge engineers face when they have to figure out what's going on miles beneath our feet in some of the most volatile conditions you can imagine.
Now, before we get to the really wild stuff, let's start with the basics. In a normal world, a well test is basically a health check. It's just a set of procedures you run to see how healthy a well is. You know, what's its pressure, how much can it produce, what's its potential down the road. Super important, but usually it's pretty routine.
But what happens when the patient isn't routine at all? Some of these wells are so powerful that a simple checkup is like trying to measure a hurricane with a kite. Yeah, these are the situations that call for a whole different level of engineering.
So this really breaks it down into the two boss levels of well testing. On one side, you've got your high-pressure, high-temperature wells. Think deep-sea vents, just this silent, crushing force. And on the other side, you have high-flow rate wells, where the big problem is just managing an insane amount of volume. Kind of like trying to take a sip from a fire hydrant that's going full blast.
So first up, let's dive into how engineers actually battle the forces of an HPHT well. I mean, this is a head-to-head fight with the raw geothermal power of the planet itself.
So what do we even mean by high pressure? Well, the official line in the sand is anything over 8,500 pounds per square inch. And to put that number into perspective,
Yeah, we're talking about pressures that would crumple a military submarine like a soda can. These are the conditions that all the equipment and the people running it have to deal with safely. It's honestly just mind-boggling.
So how on earth do you build for that? Well, you can't just go grab parts off the shelf, that's for sure. Every single piece, from the giant downhole tools they use for what's called drill stem testing, or DST, all the way down to the tiniest little seals, has to be custom designed. We're talking about special metal alloys that won't get brittle and just snap under all that stress. It is a completely different class of engineering.
Okay, so that's the silent crushing force of extreme pressure. But now let's switch gears and look at that other challenge, controlling the flood. What happens when the problem isn't the pressure itself, but an almost unimaginable volume of oil or gas trying to rush to the surface all at once?
With these wells, it's all about the sheer volume. It's figuring out how to safely channel, measure, and process a flow that would just totally overwhelm standard equipment. The key word here is control, because if you lose it, the consequences can be, well, catastrophic.
And the solution, in a nutshell, is pretty simple in concept. Go bigger. A lot bigger. Engineers use what are called large bore components. Just think of it like swapping out your garden hose for a massive industrial pipeline. Every single part of the system has to be scaled way up to give that flow a nice, wide, clear path to the surface. But once that flood actually gets to the surface, you still have to deal with it, right? This means you need huge, high-capacity equipment to separate out the oil, gas, and water. Sometimes one separator isn't even enough, so they'll link a few of them together in parallel. It's like opening more toll booths on a highway during rush hour. And then you need high-capacity burners to safely handle the hydrocarbons.
So, we've seen all this incredible, custom-built hardware for both the pressure and the flow. But here's the thing. The most important component in all of this, it isn't made of steel. It's the human element. It's the planning, the experience, and the expertise that goes into the whole operation.
And this is so crucial. Success in these environments is not about luck. It's about a rigorous, repeatable process. It starts months, sometimes years in advance, with meticulous planning to identify every single thing that could possibly go wrong. Then you have the careful selection of every last piece of equipment. And finally, it all comes down to the experienced teams who can execute that plan without a hitch.
You know, this quote from the source material just says it all. This is not a job for rookies. It really underscores the fact that no amount of fancy technology can ever replace the judgment and skill that only comes from years of hard-won experience in these kinds of high-stakes situations.
And that brings us to the ultimate takeaway from all of this. Whether you're fighting the crushing force of an HPHT well or trying to control the flood from a high-rate well, the most powerful and reliable tool you have is not the hardware. It's extreme, meticulous preparation.
So it leaves you with the final thought, doesn't it?
We've learned how to tame these incredible forces, but we're always pushing further, always going deeper. As we keep pushing engineering to its limits, what's the next frontier? What's the next untestable challenge waiting out there for us?